Hey, welcome back, physics students. Just wanted to do a couple of problems using the idea of work. So we talked about work as equaling a force that's applied over a distance. So it's a force that's in the direction of that distance. So let's think of a scenario. So let's say that this is your car, and there's something wrong with the back, probably because you hit something, or this is a spoiler because you're cool, right? So anyway, so here you are, and let's say that Bigfoot runs in front of your car. You hit him, and so here's Bigfoot. It's more like big head, huh? Here, we'll draw a Bigfoot on him. All right, so there's Bigfoot. So you've killed Bigfoot, and you're late for school though, so you need to drag Bigfoot off the road so he doesn't hit anybody else. So you connect a rope to his head, and so let's say that this is you, and so you're going to pull this rope. So let's say that when you're dragging Bigfoot, you're going to be pulling at an angle which is 46 degrees from horizontal. And let's say that you need to pull Bigfoot completely off the road into the ditch. So you're going to have to pull him a total of 15, well, let's not go feet, let's go 15 meters, right? So what is it going to take to do this? Well, when you're pulling at an angle, remember, work is only the force that is in the direction of motion. So it's actually, if you're pulling up at an angle, you're pulling both up and over. And so what you need is this vector right here, which is parallel to the direction of motion, right? The 15 meters right here. So what do? So you're just going to have to use your trig functions right here. So if we use our trig function, the cosine of the angle theta equals the adjacent over hypotenuse, this being the adjacent, it's going to end up being the cosine of 46 times let's say that your total amount of force that you can put with all of your might is 628 newtons, right? So what of that force is actually applied to the work? It's only the force that, see this force right here, perpendicular to Bigfoot, is not going to do any work at all because it's not in the direction of motion. So if we take the cosine of 628 newtons, sorry, I didn't give you that bit of information to begin with, that means that all of your power, you're only going to get out of it 436 newtons of force, right? But to figure out work, this is pretty easy because force times distance is work. So now that we've figured out the force in the direction of motion, our distance is 15 meters. So multiply those two things together, and we're going to get 6,544 joules of energy. So that's the amount of energy that it's going to take you, the change in kinetic energy that it's going to take you to pull Bigfoot off the road. Let's look at the idea, and let's do a quick little calculation on power. Okay, so we talked about power as being basically the amount of work you can do in a given time, right? So let's say that you need to get Bigfoot off the road faster, and so let's say that your maximum power output is going to be 65 kilowatts. All right, so we measure power actually in watts, and let's say that you actually are going to go 17.5 meters distance this time, and you're going to set a record for dragging Bigfoot, and you're going to go 35 seconds, right? So what is that? So here's your power. What force is that going to take? So this is your power right here, is 65 kilowatts. So let's go ahead and plug these things in. So 65,000 watts. So we measure this in watts, equals some kind of force times my distance, right? divided by my total time, which was 35 seconds. So you can see this is pretty simple to figure out. And so work, so power itself, equals force times distance over your total amount of time. Because power is just going to be a measure of how quickly you can do it. So you can imagine that if I said, okay, I'm only going to give you 15 seconds to pull him, so you're going to have more power. So this is going to be a smaller number divided into a bigger number, which is going to give you a bigger number over here. So you can see how power is just basically the greater, the smaller amount of time you can do something to do the same amount of work is going to give you more and more power. So let's go ahead and just solve this real quick. So my total force actually is going to end up 1.3 times 10 to the 5th newtons. So a lot of force in order to get that power. So let's look back at our previous equation. Let's see, we only had 6,000 joules of energy there. So that's our force times our distance, and so if our force times our distance right here, I was looking at our work and our distance is 17.5. We're going to have to get some help because there's no way that we could have done that with our earlier problem. So you can see that with what we had earlier to work with, it's going to take us a whole lot longer than 35 seconds to pull Bigfoot off, and just going to compare that way.